In the early 2000s, Honda built a car that didn't follow its own rules. While most engines were getting quieter and easier to live with, this one did the opposite. It revved to 9,000 RPM, naturally aspirated, just 2 liters, and made its power at the very top of the dial. So high that Honda had to design a tachometer just to measure it. The result was the Honda S2000, and it shouldn't exist. Not because it was too extreme, but because of what it took to build it. The kind of project where engineers stop negotiating with budgets and simply build the best thing they can. Inside a major manufacturer, that almost never happens. At Honda, it happened once, and then they walked away. So, what does it take to build a car that probably shouldn't exist? And why would you ever walk away from it? The answer starts a year earlier. It is April 1999. Honda introduces the S2000 in Japan. The timing was not accidental. Honda Motor Company was celebrating its 50th anniversary, and for one brief moment, the engineers won. Not a concept car, not a showpiece behind velvet rope, a real production vehicle, built to a brief that the accountants would never have signed off on under normal circumstances. Honda's own press materials documented it plainly. The directive was simple: show what Honda's engineers could do when the profit targets were removed from the room. That sentence sounds ordinary until you understand how rare it actually is. Every production car that reaches a showroom floor has been through a process of subtraction. Engineering wants forged components. Finance says cast will do. Engineering wants individual throttle bodies. Product planning says a single intake manifold is fine. Engineering wants a 9,000 RPM redline. Someone in a conference room points at the warranty budget. The accountants don't need to shout. They just need to be in the room. The 50th anniversary brief locked them out. The engineering targets came first. The commercial specifications followed. That reversal, documented in Honda's own communications, is the only time in Honda's modern history the company publicly framed a production vehicle as an engineering demonstration rather than a commercial product. To understand what that meant in practice, consider where the S2000 sat when it arrived in North America for the 2000 model year. The Mazda MX-5 Miata was the accessible benchmark, around $22,000, 1.8 liters, 140 horsepower. The BMW Z3 sat above it. The Porsche Boxster started above $42,000. Honda priced the S2000 at $30,695. On paper, a premium roadster competing on badge and style. But the S2000 was not competing on badge and style. It was competing on forged steel internals, individual throttle bodies, and a specific output of approximately 120 horsepower per liter, a figure the Miata, the Z3, and the Boxster could not match from a naturally aspirated engine anywhere near that price. Honda knew exactly what it cost to build the F20C to that standard. They priced the car anyway, absorbed the reduced margin, and let the anniversary brief carry the justification. The yen's strength against the dollar added another layer of pressure, the same dynamic that had pushed the Nissan 300X, the Toyota Supra, and the Mazda RX-7 out of reach for most buyers in the decade before. Honda absorbed that pressure too, rather than passing it to the customer, because the brief said the engineering achievement mattered more than the margin. That is the moment the accountants would later resent. A $30,000 Honda with a racing engine inside it, deliberately underpriced for what it contained, justified by a 50th anniversary that could only happen once. To understand exactly what that standard looked like, you have to open the hood and look at what Honda actually built inside the F20C. 1,997 cubic centimeters, 240 horsepower at 8,300 revolutions per minute. A redline at 9,000 revolutions per minute. Those numbers tell you what the F20C produced. They don't tell you what Honda had to build to make them real. Start with the crankshaft. The F20C uses a forged steel crankshaft, not cast, not nodular iron, not the cost-efficient specification that fills most production engines. Forged steel, the same material specification found in purpose-built racing engines and in the Toyota Supra's 2JZ GTE, a unit celebrated as one of the strongest production engine architectures ever made. Honda put that specification inside a $30,000 roadster because the anniversary brief said build it right before you price it. The connecting rods are forged steel too. At 9,000 revolutions per minute, the inertial loads on a connecting rod are not a road car problem. They are a racing engine problem. Honda engineered accordingly. Then there are the individual throttle bodies, 1 per cylinder, 4 total. This is a race preparation technique, the kind of intake architecture you find on purpose-built competition engines, because it allows each cylinder to draw air independently without interference from adjacent cylinders fighting for flow through a shared plenum. Honda used this same specification on the Integra Type R's B18C5 engine. So, at the end of the 1990s, Honda was the only manufacturer running individual throttle bodies as standard equipment in 2 simultaneous production cars, both priced below $35,000. That is not a coincidence. That is a documented philosophy. The valvetrain uses specific spring and retainer geometry to prevent valve float at the top of the rev range. The main bearings run tight clearances consistent with sustained high RPM operation. Honda's own service manual specifies valve clearance tolerances on the F20C that are tighter than those on the contemporary Civic or Accord 4-cylinder, a detail that only matters if you intend the engine to live at the far end of the tachometer for extended periods. And the tachometer itself is worth a moment. No standard Honda gauge of that era went to 10,000 revolutions per minute. Honda had to design a specific instrument cluster for this car. The scale is compressed above 8,000 RPM because the gradations below that point needed room to breathe, and the redline zone needed to be clear at a glance. The gauge face is a physical acknowledgement that this engine's useful operating range extends beyond anything else Honda made. Here's where it gets interesting. Below 6,000 RPM, the F20C feels ordinary, polite even. The power is present but not remarkable. Then the VTEC system engages, the character shifts completely, and the engine becomes something else entirely. The power band above 6,000 revolutions per minute is narrow by design. Honda didn't build this engine to be easy. They built it to reward commitment. Keep the revs up, stay in the band, and the F20C delivers on every number in its specification sheet. Let it drop below the crossover, and it reminds you, firmly, that it has a preferred operating range and expects you to use it. That specific output figure of approximately 120 horsepower per liter was, at the time of the SKE 2000's introduction, the highest of any naturally aspirated production engines sold in North America. Honda documented this in their own technical materials. Period Engineering Press confirmed it. It was not marketing. It was a measurable, verifiable engineering achievement produced by forged internals, individual throttle bodies, a purpose-designed valvetrain, and a brief that told the engineers to stop worrying about the warranty budget. But a 9,000 RPM heart is useless if the skeleton can't handle the pulse. That F20C produced forces that most convertible body structures simply weren't built to absorb. To keep the chassis honest under that kind of load, Honda had to rethink how a soft-top car actually holds itself together. What they came up with was equally uncompromised, and the way they achieved it is worth understanding in detail. A 9,000 ERPM engine in a soft-top convertible presents a specific problem. Convertibles are structurally compromised by design. Remove the roof, and you remove one of the primary load paths that keeps a car's body from flexing under cornering forces. The conventional solution is mass. Add steel bracing at the sill. Reinforce the door openings. Bolt in lateral cross members until the chassis is stiff enough to behave like a closed car. It works. It also adds weight, raises the center of gravity, and fights against every handling target the engineers set. Honda chose a different solution. They called it the Xbone frame. The Xbone is a hydroformed steel chassis architecture that treats the transmission tunnel as a primary structural member. Instead of routing loads through straight longitudinal rails, the structure distributes impact and torsional forces through an X-shaped path across the vehicle's floor. The transmission tunnel, sitting at the center of that X, becomes the spine the whole structure works around. Rigidity through geometry, not through mass. The hydroforming process itself is worth understanding because it connects the S2000 to an unlikely companion. The Corvette C5 uses hydroformed frame rails built on the same manufacturing principle. In both cases, high-pressure fluid shapes steel tuning from the inside out, producing continuous curved members without the weld seams that conventional stamped and welded construction creates at stress concentration points. Weld seams are where metal fatigues. Eliminating them at the points where loads are highest produces a structurally honest frame, one that doesn't rely on a weld to hold together exactly where it matters most. Honda's documented torsional rigidity target for the S2000 was higher than the contemporary Mazda MX-5 Miata. The Miata is not a soft chassis. It is a thoughtfully engineered small roadster that had been refined across 2 generations by the time the S2000 arrived. Exceeding its rigidity figure in a convertible, without resorting to the conventional mass-adding approach, required the Xbone's geometric solution and the manufacturing investment to build it at low volume. That investment shows up in the way the car behaves. There is no scuttle shake, no much flex through the cowl when one wheel drops into a road imperfection. The body feels solid in a way that most convertibles of the era did not, and the reason is not that Honda added reinforcement until the problem went away. The reason is that Honda designed a structure that didn't need reinforcing in the first place. The 50-50 front-to-rear weight distribution follows the same logic. It was not arrived at by accident or by adding ballast to the rear. It was achieved by positioning the F20C's center of mass behind the front axle centerline. The engine sits ahead of the firewall in the conventional sense, but its heaviest mass sits behind the line connecting the 2 front wheels. Honda's service manual dimensional drawings document this position precisely. The result is a front midship layout, the same principle that gives mid-engine cars their handling neutrality applied to a front-engine architecture. The practical consequence is a car that steers from its center rather than from its nose. Understeer, the default behavior of most front-heavy sports cars, is not the S2000's natural tendency. It wants to rotate. It wants the driver engaged, making decisions, holding the balance through the corner. Every input has a direct, unfiltered response. No vagueness, no delay. That precision, as Honda would discover, had a limit that only appeared when the car was pushed hardest. The S2000 was built to be driven hard. The F2OC's entire character demanded it. Stay in the rev range, commit to the corner, trust the chassis. That was the operating philosophy Honda engineered into the car from the beginning. So, owners drove it hard. They took it to track days. They ran it through sustained corners at speeds that exposed every engineering decision to real-world consequences. And on early AP1 examples, something began happening that Honda had not fully anticipated. The engine was losing oil pressure, not under braking, not under acceleration, under sustained high G cornering, exactly the condition the car invited, and the driver was rewarded for pursuing. Rod-bearing damage followed in the most severe cases. The failure pattern was specific, repeatable, and rooted in straightforward physics. The F20C uses a wet sump lubrication system. Oil sits in a reservoir at the bottom of the engine. A pickup draws it up and circulates it through the bearings and valvetrain, and gravity returns it to the sump. That system works perfectly under the conditions most road cars ever encounter. Straight-line acceleration, moderate cornering, normal road use. What it wasn't fully calibrated for was the sustained lateral G of a proper track corner, held at its limit for several seconds continuously. Under that kind of force, oil in the sump migrates sideways, away from the pickup, in the same direction the centrifugal force is pushing everything else in the car. The pickup, positioned centrally in the sump for normal conditions, finds itself exposed to air instead of oil. Oil pressure drops. The bearings, running on tight clearances designed for sustained high RPM operation, get nothing. Honda's response was a technical service bulletin, specifying installation of an oil baffle plate inside the sump. The baffle limits lateral oil migration by containing the oil closer to the pickup under cornering loads. Honda documented the failure mode, identified the physics behind it, and produced a specific engineering fix. That TSB is one of the most detailed primary source analyses of wet sump lubrication behavior under competition loads available for any production crew. Honda didn't bury the problem. They described it precisely and solved it with hardware. The baffle retrofit became standard preparation procedure in the S2000 owner community. Cars that received it are documented as durable at sustained track use. The failure mode, in practice, belonged to a specific window of early ownership before the fix became widely known, not to the F20C's fundamental architecture. Here's the honest read on this. The oil starvation problem is not a condemnation of the F20C. It is evidence of an engineering team that built a road car capable of reaching a performance threshold that most production vehicles never approach. The limit wasn't low. The limit was so high that finding it required a racetrack. For the engineers, the oil baffle fix was almost a badge of honor. Proof that the car was operating at a threshold most road cars never approached. The limit wasn't a design flaw. The limit was evidence of how far they had pushed it. But inside Honda's boardrooms, a track day liability reads differently than it does in an engineering debrief. And by 2004, the voices asking for a broader power band and a more forgiving chassis had grown louder than the ones asking for a higher redline. 2004, Honda introduces the AP2. The engine is the F22C1, 2,156 cubic centimeters, up from the F2OC's 1,997, 237 horsepower at 7,800 RPM, redline at 8,200 RPM, 800 RPM lower than the AP1. That gap is not a rounding difference. It is a philosophical statement. To understand why Honda made this change, you have to understand the criticism the AP1 absorbed throughout its production run. It was consistent, it came from press and owners alike, and it was not entirely unfair. The F20C's torque lived almost entirely above 6,000 RPM. Below the VTEC crossover, the car felt ordinary in a way that its 240 horsepower rating did not prepare drivers for. You could sit at city speeds, at motorway cruise, at the kind of RPM a normal driver uses on a normal day, and the S2000 would feel no more urgent than a well-sorted economy car. The power was there. It was just elsewhere. It required effort and commitment to access every single time. Honda listened. The F22C1's larger displacement broadens the torque curve, more mid-range response, power that arrives earlier and stays more accessible across a wider RPM window. The VTEC crossover point shifts lower. Drivers who criticized the AP1 for feeling lazy below 6,000 RPM found the AP2 easier to use, more rewarding in everyday driving, more forgiving of the moments when holding the revs high simply wasn't practical. The suspension geometry was revised too. The AP1 had a documented tendency toward oversteer at the limit, corner exit rotation that experienced drivers described as engagement, and that less experienced drivers described as a handful. Honda addressed it in the AP2 with revised rear suspension geometry and revised spring rates, producing a more neutral balance at the limit. Progressive, predictable, accessible, period press welcomed the changes. The AP2 was acknowledged as a more rounded, more complete sports car in everyday terms. Experienced drivers documented something else. The F20C's specific character, that demanding, uncompromising insistence on living above 6,000 revolutions per minute, was gone. The 9,000 revolutions per minute redline had become 8,200. The engine that required commitment now offered convenience instead. The suspension that rewarded the driver who could manage rotation now simply handled. The AP2 is a better car in the way a smooth road is better than a challenging one. Easier, less demanding, and less alive. The market has delivered its verdict on this quietly and consistently. Bring a trailer auction records document, a persistent pricing premium for AP1 examples over comparable AP2 examples. The mechanical difference between the two cars is not dramatic on paper. The redline drops 800 revolutions per minute. The displacement grows by 159 cubic centimeters, but the market has put a specific dollar value on that difference. And the dollar value consistently favors the AP1. Collectors are not paying a premium for the older car out of sentimentality. They are paying for the 9,000 RPM redline, the demanding power band, the engine that required something from the driver and gave something extraordinary in return. The AP2 is not a bad car. That point deserves to be made plainly. It is a very good sports car, but the AP1 was something rarer than a very good sports car. Honda made one final statement before closing the door entirely. Honda did not go quietly. For the 2008 model year, Honda released the S2000CR Club Racer, a factory specification that read like a list of decisions made by people who still remembered what the original brief had said. The interior was stripped, air conditioning deleted, the roll-up glass side windows replaced with sliding polycarbonate panels, the kind of solution a race car preparer reaches for when the priority is weight reduction and simplicity over comfort. Honda didn't adapt the idea from motorsport and dress it up in production language. They took the track solution directly and made it a factory specification, documented in Honda's production records, distinguishable from a standard AP2 by the door panel design and the absence of window switch provisions, sliding plastic where glass had been. That detail alone tells you what the CR was about. The suspension was stiffer. A front lip spoiler and a rear wing were added, the only factory S2000 ever fitted with aerodynamic downforce provisions. Ray's forged wheels replaced the standard units. The interior lost weight wherever Honda could justify the deletion without compromising what remained. The CR is the highest performance factory S2000 ever produced. It is the most honest expression of what the S2000 was always capable of being when you remove the concessions to everyday usability and let the engineering intention breathe without interference. But there is a detail inside the CR that matters, and it sits in the engine bay. The CR uses the AP2's F22C1, not the AP1's F20C, 8,200 RPM, not 9,000. Honda's final, most uncompromised factory S2000, the one with the sliding plastic windows and the deleted air conditioning and the rear wing, carried the revised engine rather than the original. Even the last true intention carried the compromise of its generation. That tension between the purity of what the CR represented and the engine beneath its hood is a fair summary of where Honda was by 2008. The ambition was still present. The willingness to strip a car to its essentials and call it a factory product was still there, but the specific character of the F20C, the 9000 RPM redline, the demanding narrow power band, the engine that required something from the driver, was already 4 years gone. The CR was the clearest signal of what the engineers still wanted to build when nobody stopped them. Stripped to its essentials, fitted with a rear wing, running on sliding plastic where glass had been. A raw, honest, uncompromised factory product that read like a direct challenge to every cost-benefit meeting that had softened the AP2 3 years earlier. But even as the last club racer left the Takanazawa line, the decision had already been made at a level the engineers couldn't reach. The era of the naturally aspirated, high-revving roadster was being traded for a quieter, more efficient, more commercially defensible future. The CR wasn't a preview of what was coming next. It was the door closing. The S2000 ended in June 2009. No special final edition, no ceremony. The last units produced were standard AP2 specification, the same quiet exit the Porsche 993 had made at the end of its own run. Production stopped. Honda confirmed no replacement was planned. The door closed without a sound. June 2009. The last S2000 rolls off the Takanazawa line. Honda's public statement framed the discontinuation around evolving fuel economy standards and the company's strategic direction toward electrification. That framing was accurate. It was also a clean way of saying that a naturally aspirated 9000 RPM roadster was no longer compatible with where Honda had decided to go. Sales had been declining for years. From the early production peak of approximately 6,000 to 9,000 North American units per year, the numbers had fallen to roughly 2,000 to 3,000 units annually by 2007 and 2008. The 2008 financial crisis accelerated the contraction of the discretionary sports car market across the industry. The S2000 was not uniquely vulnerable, but Honda, unlike some manufacturers, chose not to sustain the segment through the difficulty. No replacement was announced. None has been produced. What Honda built instead tells the story more clearly than any official statement could. The Civic Type R arrived, turbocharged and front-wheel drive, technically extraordinary, genuinely fast around a circuit, and built on a completely different philosophy. It is a precision instrument in the way a surgical robot is a precision instrument. Efficient, measurable, optimized. The driver is served by the technology. The technology does not ask anything of the driver in return. The Type R holds lap records. It also holds them without the narrow power band, without the manual-only global specification, without the 50-50 weight distribution of a front midship layout, without any of the specific decisions that made the S2000 feel like a contract between the car and the person behind the wheel. The second-generation NSX arrived in 2017. 3 electric motors, a twin-turbocharged V6, all-wheel drive through a sport hybrid system of considerable complexity. It is an engineering achievement of a different order entirely, the kind of car that requires a technical briefing to fully understand what is happening beneath the surface at any given moment. The original NSX was celebrated because it distilled driver involvement into something pure and Japanese. The second-generation NSX is celebrated for its systems integration. Those are different celebrations. Honda's corporate priorities in the years following 2009 are documented plainly in its product decisions. The Insight Hybrid, the Civic Hybrid, the electrification roadmap that shaped Honda's global strategy through the 2010s and into the current decade. These are not wrong directions. They reflect real priorities around real problems. But a naturally aspirated sports car with forged internals and a 9,000 RPM redline is a poor fit for a company whose engineering brief had shifted from maximum specific output to maximum efficiency. The community that formed around the S2000 has waited since 2009. Patent filings and concept studies have kept the conversation alive. Honda has offered nothing confirmed in return. The S2000 was not canceled because it failed. Annual sales of several thousand units across a decade of production is not failure for a specialist sports car built at a dedicated low-volume facility. It was canceled because Honda changed what it valued, and what it valued no longer had room for an engine that required its own custom tachometer because no standard Honda gauge went high enough to show where it actually lived. That shift in values is where the real story of the S2000 ends. There is a version of Honda that still exists in the engineering records. It exists in the F2OC's service manual, in the tighter valve clearance tolerances, in the dimensional drawings that show the engine's center of mass sitting behind the front axle. It exists in the technical service bulletin that describes, with engineering precision, exactly what happens to oil under sustained lateral G at a racetrack. It exists in the production documentation for a Club Racer edition that deleted the power windows and replaced them with sliding plastic, because the track solution was more honest than the comfortable one. That Honda believed the driver was the point of the exercise. 120 horsepower per liter, naturally aspirated, in a $30,000 car with forged steel internals, individual throttle bodies, a purpose-designed tachometer, and a 9,000 RPM redline. That combination has not been repeated. Not by Honda, not by anyone else at that price point. It existed once, for a specific reason, because a 50th anniversary brief told a group of engineers to stop negotiating with the accountants and simply show what they could do. What they could do was the S2000. The Civic Type R proves Honda did not forget how to engineer. Its lap times are documented, its development is rigorous, its execution is serious. But engineering in service of lap times is different from engineering in service of sensation. The Type R optimizes the driver's experience of performance. The S2000 demanded the driver's participation in it. Those are different philosophies, and only one of them produced a car that required a custom gauge cluster because the standard instruments weren't built for where it actually lived. The SS2000 was the last Honda that felt like it was built for the person behind the wheel first, and for everything else second. That is not nostalgia. That is what the engineering brief documented, what the forged internals confirmed, and what the 9,000 RPM redline made audible every time someone kept their foot in it and held on. Honda knew how to build a car with a soul. They did it once, completely, and walked away. Think about that custom tachometer one more time. Honda's engineers needed an instrument that didn't exist yet, so they built one. A gauge face designed around an engine that lived above 8,000 RPM with a redline zone drawn clearly at 9,000 because nothing in Honda's standard parts bin went that high. That tachometer wasn't a styling choice. It was an admission. The engine had outrun every measuring tool the company already owned. That is what the accountants eventually closed the door on. Not just a sports car, not just a segment. The version of Honda that built instruments to keep up with its own engineers, rather than building engines to fit the instruments it already had. The S2000 is the warning. When the brief changes, when efficiency replaces sensation as the headline target, the cars that follow are technically impressive and spiritually quieter. The Civic Type R holds lap records. The second-generation NSX integrates 3 electric motors. Both are serious machines. Neither one required a custom gauge cluster because the standard parts couldn't measure where the engine actually lived. That detail is not nostalgia. It is a precise description of something that happened once, completely, and has not happened since. If you value engineering built to last, the next video is about the Mercedes W124. The last Mercedes so obsessively over-engineered, it made Lexus nervous, until the accountants replaced it with one of the most problem-filled cars the company ever made. Click on it now.